Good morning, students. Yesterday we have done about electromagnetic wave theory, and we have got uh, light possesses radiation, and radiation have the wave character. And to know about wave, I think you know wave have some characteristics property. A wave contain definite wavelength. A wave have definite frequency. Wave have wave number. So you should know what is wavelength, what is frequency, what is wave number. So now today I will give you some characteristics property of wave. Number one, wavelength. Wavelength is one of the property of wave, and it is symbolized by the symbol lambda. What is wavelength? It is the distance between two consecutive crests or two consecutive trough is called wavelength. Suppose this is one of the wave. From this point to this point, what is the distance? That distance is called wavelength, which is represented by lambda. So it is the distance between two consecutive crests or two consecutive trough. Now these wavelengths, these are very small. That is why these are always measured by using the unit nanometer, picometer, Armstrong. This type of units are generally used to express the wavelength, because the lengths are very small. That's why this type of units are used. Already you have got 1 nanometer means, if you want to convert in meter, 10 to the power minus 9 meter. 1 picometer means 10 to the power minus 12 meter. 1 Armstrong means 10 to the power minus 10 meter. So like this way you can convert to meter or centimeter. You should know about this relation. But wavelength always you will get in terms of nanometer, picometer or Armstrong. That is why when you do numerical, if you want to find out lambda, suppose the answer you get in meter, then always you try to convert either in nanometer, picometer or Armstrong if you find out the wavelength, because wavelength is very small. Another property of the wave is frequency. That is number 2, frequency. Frequency, it is symbolized by the symbol nu. What is frequency? It is the number of waves passing through a point in 1 second. Passing through a point in 1 second. its unit is second inverse, or you can represent by hertz also. Hertz and second inverse both are same. Hertz is represented by Hz. So in 1 second, how many waves are produced? That is called the frequency, and its unit is second inverse. Another property of the wave, that is number 3, which is called velocity. Velocity, it is represented by symbol c. Positive. Velocity, it represented by c. And what is velocity of wave? It is the linear distance it is the linear distance traveled by it is the linear distance traveled by 1 second. That is called velocity, and its unit is meter per second. Another property of wave, that is number 4, which is called wave number. Wave number, it is represented by the symbol mu, then you have to write one bar. Mu bar is the symbol of wave number. And what is wave number? It is the number of waves present in 1 centimeter length. In 1 centimeter length, how many waves are present? That is called wave number, and which is represented by mu bar. And if you want to find out mu bar is the reciprocal of wavelength. I mean, mu bar is equal 1 by lambda. So that is why if you know the wavelength, you can find out wave number. Similarly, if you know wave number, you can find out the wavelength for this wave. So these are the main properties of wave. Now you should know some relation among these properties. One of the important relation you should know, lambda into nu equals c. I mean, lambda means wavelength, nu means frequency, wavelength into frequency is equal to velocity. And as you know, wave have the velocity equal to the speed of light. So c is nothing, c is the speed of light, and c value is constant, that is 3 into 10 to the power 8 meter per second. So that is why if you know wavelength, you can find out frequency. Similarly, if you know frequency, you can find out wavelength, because c is constant, you know, and its value is 3 into 10 to the power 8 meter per second, because the radiation always possesses wave character and it travels with the speed of light. Already you have got that point. I mean, it has the speed equal to the speed of light, 3 into 10 to the power 8 meter per second. So in your book, you will get some numerical. The wavelength is given, you have to find out frequency. The frequency is given, you have to find out wavelength. That type of questions are given in your book. So you can do it by applying this relation. Suppose only time period is given. For example, suppose 10 seconds, only time period is given for the wave. You have to find out wavelength, frequency, then wave number, everything. So if time period is given, then frequency, when you determine, always you do 1 by time. When you do 1 by time, you will get the frequency. Again, lambda into nu is equal c. C value you know, so lambda you can find out by doing c by nu. As you have got nu, that nu value you can put here. So like this way you can find out frequency, you can find out lambda, and when you get lambda, you can find out wave number also. Wave number is equal 1 by lambda. So like this way, if time is given, if the period is given, you can find out frequency, then you can find out wavelength, then you can find out wave number also. So this type of numerical you will get in your textbook, and you try to do it. Thank you.